Hello everyone, and welcome to lesson number 10 of my deep learning course. In this lesson, we will train and improve the performance of our multi-layer perceptron. So, without further ado, let's get started.
Whether you want to implement AI into your business or you just need consultancy from a machine learning expert, I'm the right person for you. From acquiring data till deployment, my multiple years experience will provide you full support which will help you to boost your business. To find out more, check the link in the video description.
Welcome back everyone. This is the final part 3 on learn how to solve your first deep learning task. In this Jupyter notebook we will train our neural network for our task, as well as learning a new loss function. If you guys have missed lesson 8 or lesson 9, I strongly recommend to start from those lessons first and then come up here. If this is the first video of my series that you guys are watching, I strongly recommend to start from lesson 1, where I explain how to set up the Jetson Nano for deep learning, and then from that point you can continue the series. First of all, I want to start by saying that at the end of this lesson, then we will have finished the first module of this deep learning course. I hope you guys enjoyed and you like it. So far, I've seen it's pretty positive, the comment that I'm getting from you guys. But if you have any suggestion on how to improve, let me know in the comment down below. From the next lesson onwards, then we will learn also other new things, of course, but we will focus more into projects, so in real-world applications. As always, guys, you can find the link from where to download the Jupyter notebook of this lesson in the video description. As always, here at the beginning of the Jupyter notebook, you can find the video of this lesson. Don't forget to like, subscribe, and activate the notification bell. So let's start by ensuring that our Jupyter notebook is running on the TensorFlow 2 virtual environment. So we execute this code. If you guys get any error, as always, you can go up here and into switch kernel and select TF2. Now, of course, we're going to use the same exact neural network class that we used from lesson 9. So here I'm just going to skip. If you guys want to know more about it, you can ask me in the comment down below, or you can also watch the lesson number 9. So now we execute the code. And we start by explaining a new loss function. Now, along having the usual mean absolute error, we will create another loss specific for classification tasks, cross entropy. In this case, since we are dealing with binary classification, we will implement binary cross entropy loss from scratch, as always. So the formula is as following. The loss is equal to minus y is the label, times the natural logarithm of y hat, or the prediction, minus 1 minus y times natural logarithm of 1 minus y hat, where, as I mentioned, ln is the natural logarithm, y is the label, and y hat, or y prime, is the estimated probability of belonging to the positive class. One thing to notice here is that when y is 0, so when the label is 0, the loss is computed as minus natural logarithm of 1 minus y prime. And we can see it because when y is 0, this part of the function becomes 0. And then minus 1 minus 0 is 1. So minus 1 is equal to minus natural logarithm of 1 minus y prime. And when y is 1, the loss is computed as follows, which is minus natural logarithm of y prime. Why this? Because of course then when y is 1, then this part of the equation becomes 0 and then remains only this part. I think that many of you guys already know about binary cross entropy, but have you ever wondered why is this loss function always used for binary classifications? Always, if not always, but very often. Let's find out. In this block of code, I've implemented two loss functions, so binary cross entropy and mean absolute error. So what I'm going to do here is trying to make a comparison and see in different scenarios how much is going to be the loss in case of binary cross entropy and mean absolute error. So going into the binary cross entropy, the only thing, apart of writing the formula that I mentioned before, I wanted just to make sure that we never apply natural logarithm of 0. So I always check that y hat, so the prediction, is within 0 and 1, but never either 0 or 1. So that's why I have this epsilon value, which is almost can be ignored. And then the formula, we have it as before. For the mean absolute error, that's pretty straightforward. So we have y and minus y hat, and then the absolute value of it. So we can execute this code. And now we can see that in case the prediction is correct, so y was 0 and y hat is 0, for both binary cross entropy and mean absolute error, both cases the loss would be 0. Same case in which we have a prediction for y is equal to 1, and the prediction is also 1, so again the loss is 0 for both. In case we have a scenario in which the prediction is 50%, so neither one side or the other, then in case of binary cross entropy, we see that we have a higher loss that come back from the function instead of mean absolute error. Mean absolute error is simply 0.5, but in binary cross entropy is almost 0.7. So it has a higher influence when it's making false prediction. And then we can also see here, when it's a little bit further from the actual prediction, the loss is always a bit higher than the mean absolute error. When the prediction is completely misclassified, so the prediction is 1 and instead the label was with 0 or vice versa, the binary cross entropy loss is very, very high, so 16.1. While instead for the mean absolute value it was only 1. So what does this mean? This means that when the network is making something wrong, it's going to be badly penalized using binary cross entropy instead of comparing with the mean absolute error. Now, in this block of code, I simply recreate the same that I did before, but just to apply it for TensorFlow operations so that we can use it in our neural network. So now that we have clarified the loss function, we have to create a data generator to train our neural network, since the one from lesson 9 was just a dummy one, as I mentioned. To be efficient, we will create a function that accesses the HDFI file created in lesson 8, convert the data into constants, and finally yield the data. So here this function is pretty straightforward, except two parameters: dataset type, which can be either row, SS for standard scalar, or MM for min-max, and then the batch size, so the size of the batch that we want. And after some type checking and figure out what kind of dataset we want here as a string, since we're going to access that string, then we retrieve the data and we store it in memory just to be a bit faster and not always to access from the memory, physical memory of the Jetson Nano. And then we loop forever, but we don't simply return some random data. What we do instead is that we go through the entire data and then we yield one batch at a time, and then we're going to shuffle the data and then loop forever. This is very important because if we just return every time some random values, then we are not sure that we go through the entire data every single time. So in this case, instead we go through the entire data, then we shuffle the data so that we don't repeat the data every time the same way, and then we repeat the same procedure over and over again. Now it is finally time to create the neural network and train it. But what I want you to do, those are some parameters that I use, but I really want you guys to try and experiment. By experiment here, you can play along with how many layers you want to add, what kind of activation function to use, what about the batch size, the dataset types, because remember we have 3 types of dataset, for how many steps we want to train, and also try the difference between mean absolute error and binary cross entropy. So in this case, I have a neural network with 4 layers. The 3 hidden layers have 100 neurons each. And then there is the final layer. I use the ReLU activation function and the parameters here. But I really want you guys to try out different combination and see what happens. Let me know in the comment down below what are your results. If you face some error, if there is something that you don't understand, we can just ask some question and I will reply to you. Okay, now as you can see, the network has trained. We can see the loss decreasing, so it gets to a pretty low value, but it's difficult for us now to see how are the performance, so how many times what about the accuracy, right? So we need some metric to give a score of how the network is performing. Okay, now that the neural network has trained, it is now time to see how the network performs on the test dataset. Since the dataset is balanced, as we saw in lesson 8, we can score the performance of the network with simple accuracy. So here I wrote 2 functions, get test data, which just returns the data itself contained in the file, and then another function to calculate the accuracy. So we execute this code, and we can see that the network's accuracy is 96.7%, which are very good results, but of course can be improved even further. So that's what I want you guys to do. Try, experiment, and see if you can get a higher score, and let me know in the comment down below what have you done and what's your highest score. This task was pretty simple, and the data, the test data, is in the same distribution as the training data. So overfitting is still very likely to happen, as I mentioned in lesson 8. Since it's the same distribution, there is not much of a proof for us to see whether the network really is doing a good job on some unseen data. If you could understand everything from lesson 1 until now, congratulations, we just finished the first module. In the next lessons, we will make more exciting exercises using a simpler API.
So that's it for this video. If you guys like my content, you can support me on Patreon, where you can speak directly with me, and also I can give you advice on how to get started into this career. Another way to support this channel is to use my affiliate link that I give you in the video description for your purchases at no cost for you. Finally, another way to support me is to subscribe and share this video on social media. So I thank you for now, and I hope to see you in my next video.